260,000 tons of ultrapure water. That is not a lake, not a reservoir, not a municipal supply. That is the payload of a single cylindrical tank being assembled 600 meters inside a mountain in Japan. And it will weigh more than the steel and rock around it can be trusted to hold if the engineering slips by a fraction. The mountain is Mount Ikeno in Gifu Prefecture. The tank is Hyper-Kamiokande, and it will hunt neutrinos, ghost particles that pass through your body by the trillions every second without leaving a mark. But here is what nobody tells you about building a detector that pure. The water itself is the enemy. You cannot just pour 260,000 tons of water into a cavern and start counting flashes. The water must be so clean that it would dissolve a copper wire left in it for a month. The tank must be so dark that a single photon of light, one particle of light, not a beam, not a ray, one, can be caught by a sensor the size of a beach ball. That is the promise of this video. How you carve a hole in the earth big enough to hold a cathedral, then fill it with nothing, then use that nothing to see the invisible. Here is what nobody tells you about drilling through rock at 60 degrees. The heat, the humidity, the air itself gets heavy. You are going to descend with me, block by block, through every layer of this build. And by the time we reach the bottom, you will understand why this single hole in the ground is harder to build than any skyscraper. And why, when it goes wrong in ways that have nothing to do with the rock. You have stood in front of a closed steel door underground and felt it. The pressure, the silence, the weight of everything above you pressing down in a way you cannot see. That is the first thing you feel at the Kamioka Mine. Not the dark, though the dark is complete. Not the cold, though the rock bleeds cold into your boots. It is the weight. The mine has been here for over a century. It started as a working mine, tunnels cut by hand and machine into the mountain's heart. Then physicists came, because physics has a strange need. It wants to hide. Cosmic rays scream down from space and drown out the whispers of ghost particles. The rock above you is not an obstacle. The rock above you is a shield. 600 meters of mountain absorbs the noise. That is what you become down there. A listener in a silent room. But before you can listen, you have to build the room. The plan is simple on paper. A cylinder, 68 meters across, 71 meters deep. A cavern carved out of solid rock, then lined, then sealed, then filled with the purest water humans have ever produced. The mathematics are brutal. Every square meter of that tank's wall must hold back water, pushing with the force of a small ocean. If you have ever watched a single crack in a dam and felt your stomach drop, you already understand the stakes. Except a dam fails in daylight. This fails in darkness, under a mountain, with no one to see it coming. The rock above your head does not negotiate. Two loops open here, and you will not close them easily. The first is the water itself. How do you make something pure enough to see a ghost? The second is the cavern. How do you carve a space big enough to hold a cathedral without the mountain deciding to claim it back? The first crack in the simple story appears when you actually go underground. You expect a hole. You do not expect a construction site the size of a sports stadium, with haul trucks and ventilation ducts and crews working in shifts around the clock. The excavation took almost 3 years. Think about that. 3 years of cutting rock, not building a detector, just making the space empty enough to build it in. The final cavern measures 69 meters in diameter and 94 meters tall. That is not a room. That is a void. Here is what nobody tells you about creating a void that large underground. You cannot just dig a hole. The mountain wants to close it. Rock creeps, it shifts, it settles. Every blast, every scoop of muck, every meter of progress reduces the structural integrity of what remains. You are not removing rock. You are removing the support structure that has held this mountain stable for millions of years. The mountain wants the space back. That is not a metaphor. It's rock mechanics, slow and patient, and every blast gives it an opening. Subscribe now, or you will miss the part where engineers fight geology with nothing but steel and nerve. Drop the word void in the comments. It means something different down there. The crews used tunnel boring machines for the access tunnels and drill and blast for the main cavern. Explosives, carefully placed, detonated in sequence to break the rock without shattering the surrounding mass. You feel the blast through your boots before you hear it. A low thump that travels through the mountain, then the rumble, then the dust that takes hours to settle. And when the boom fades, there is the smell. Wet granite, fresh rock, ozone from the machines, diesel from the haul trucks. The air is thick, almost breathing on its own. Your lungs remember it. Your eyes water, not from dust, but from the sheer mineral weight of the atmosphere. Here is where the first loop starts to tighten. They carved the cavern. Then came the hard part. Not the rock, but the water. The pattern is simple. It is also a lie that hides a deeper truth. Remove rock, add liner, seal the tank, fill with water. 4 steps. A child could describe them. An engineer weeps at the details. The liner is the first betrayal. The cavern walls are rough, fractured, unreliable. Before a single drop of water touches them, they must be made smooth, sealed, and structurally sound. Concrete, sprayed and poured, layer upon layer, until the irregular stone becomes a perfect cylinder. You have seen concrete before. You have not seen concrete poured 69 meters across, in a space where one mistake means the entire lining buckles under pressure it will face for decades. Stop. Think about that number. 69 meters in diameter. The water inside will push outward against that lining with the weight of 260,000 tons. If the concrete has a single flaw, a single air pocket, a single weak seam, the pressure will find it. Water does not care about your schedule. Water does not care about your budget. Water finds the crack, and it waits. The sensors are the second betrayal. More than 20,000 of them, each 50 centimeters across, lined along the tank's inner walls. They are called photomultiplier tubes. Think of them as eyes that can see a single photon and amplify that flash into a signal big enough for electronics to read. 20,000 eyes staring inward at a pitch-black body of water. You have held a flashlight in a dark room. You know how far light travels, how it scatters, how it dies. In ultrapure water, light travels further than you can imagine. But it still dies. The entire detector is a race. A photon is born, and you have a few billionths of a second to catch it before the water swallows it. The mirror moment hits you here, if you let it. If you have ever stood in a completely dark room and seen a single flash, a camera, a spark, a distant light, and known exactly where it came from because nothing else in the room could produce it, you understand the principle. The only difference is scale. 20,000 eyes staring at nothing, waiting for a ghost to flicker. This is the part most people miss. The water is not just water. It is the detector. It is the lens. It is the target. And it must be so pure that no one has ever made water this clean at this scale before. 260,000 tons. Every single ton must be filtered, purified, processed, and cycled through the tank in a constant loop. The water is not filled once and forgotten. It is continuously filtered, continuously monitored, continuously stripped of anything that could cloud it or absorb light. You think about what that means. Minerals from the rock, dissolved into the water, would absorb photons before they reach the sensors. Microorganisms, if any survived the filtration, would grow, die, and cloud the medium. Even the water molecules themselves can scatter light, if you push the physics hard enough. You have boiled water to make coffee. You have seen a glass of water sit in sunlight and slowly grow green with algae. You understand the problem. The engineers have to build a system that removes every impurity, every dissolved ion, every microscopic organism, and keeps it out forever in a tank the size of a cathedral, 600 meters underground, in a mine that was never designed for cleanliness. The water system is a machine of its own. Filters, resins, ultraviolet sterilizers, reverse osmosis units. The water circulates constantly through a treatment plant that would dwarf most municipal supplies. And the entire thing runs on the assumption that nothing will fail in a way that lets contamination in. Here is the pivot you didn't see coming. The water is not the hardest part. The cavern is not the hardest part. The hardest part is what happens when the two meet. When the water starts testing everything the engineers built, and the mountain starts testing everything back. Pause for a second. You are 600 meters down. You are standing on a floor of freshly poured concrete, looking up at a cylinder of rock and steel that will hold 260,000 tons of water. The air is humid. The lights are industrial, harsh, casting long shadows across the surface. You can hear the ventilation system, a low mechanical hum, a rhythmic pulse that never stops. And then you notice the other sound, the rock. That sound you just noticed, that is the mountain testing back. Subscribe to follow every descent deeper into the impossible physics. When you do, comment pressure, because that groan is exactly what thousands of tons of rock sounds like when it's waiting for a mistake. It groans, not loudly, not dramatically, but it does not stay silent either. The mountain is still settling, still adjusting to the void that was carved in its heart. After 3 years of excavation, the rock has found a new equilibrium, and it announces itself in low creaks, deep thuds, sounds that travel up through the concrete into your boots. That sound is the whole game. Every engineer in that cavern knows that the rock is not their friend, their ally, or their substrate. The rock is a living pressure vessel, and you have just cut a hole in its side. What if that sound gets louder? What if the creep accelerates? What if the fractures open wider than the models predicted? There is no backup plan. There is no evacuation tunnel that helps. If the mountain decides to fail, it fails in seconds, with no warning that any instrument can read. The second loop closes here, and it closes with a grim fact. The team did not simply carve the cavern and move on. They studied it. They monitored it. They installed instruments to measure micro-movements, stress changes, acoustic emissions. And they made design decisions based on what the rock told them. Changing the thickness of the liner in places, adding support bolts where the stress was highest, adjusting the shape of the access tunnels to redirect the forces. You will never see those decisions. No photograph captures them, but they are the difference between a detector that works for decades and a cavern that collapses in the night. The rock is not the enemy. The rock is the customer, and you had better learn what it wants before you fill the tank. You think the answer is concrete. You think the answer is steel. You think the answer is the liner, the seal, the waterproofing membrane. And those are all real. They are all critical. They are all the things you would name if you were listing the layers of defense between the water and the mountain. But that is not the real problem. The real problem is contamination. The real problem is the water itself and what it does to everything it touches. You have seen what happens when you leave a steel pipe in water. You have seen the rust, the scaling, the slow degradation. Now scale that to a tank holding 260,000 tons of ultrapure water, and every single component, the liner, the seals, the sensor housings, the cables, the support structures, is constantly being tested by the most chemically aggressive substance on Earth. Ultrapure water is hungry. It leaches ions from everything it touches. It dissolves materials that would seem indestructible. It corrodes metals that are rated stainless. It is not a neutral medium. It is a solvent, and it is always working. The gasket that seals a sensor to the tank wall might be rated for decades, but in contact with ultrapure water, at depth, under pressure, it will degrade. The degradation products will enter the water. The water will then absorb a photon that should have reached a sensor. A neutrino interaction, an event that happens once in a blue moon, that a physicist has spent their career waiting for, will be missed because a seal failed. You understand the irony. The entire detector is built to catch the rarest, faintest signals in the universe. And the only thing that can stop it is a leak, a flaw, a speck of contamination that has no respect for the physics. Here is what changes everything. The team does not just build the tank and fill it. They build a system that continuously purifies the water, continuously monitors the purity, continuously cycles the entire volume through filters that strip out anything that has leached in. The water is not static. The water is alive, constantly moving, constantly being renewed. You have never thought about water this way. Most people never do, and that is the whole point. The revelation comes when you stop thinking about the detector as a machine and start thinking about it as a single enormous eye. The rock is the eyelid. The water is the lens. The 20,000 sensors are the retina. And the entire assembly is wired into a control room on the surface, where the faint signals of the universe are decoded into data. A neutrino arrives. It strikes a water molecule. A charged particle is produced, traveling faster than light can travel in water, which is possible because light in water is slower than light in vacuum. The particle emits a cone of blue light called Cherenkov radiation. That light expands outward in a ring, strikes multiple sensors, and the pattern of hits tells physicists the direction, energy, and type of the particle. You have seen a boat leave a wake. You have seen a crack form in a windshield and watched the lines radiate outward. That is the same physics. A particle moving through a medium faster than the speed of light in that medium leaves a wake of light. The sensors catch it. The pattern is the message. The physicists do not care about the water. They care about the light. The water's only job is to be so clear that the light can travel far enough to be caught. And that single requirement, that purity, that darkness, that silence, is what turns an ordinary hole in the ground into the most sensitive eye ever built. Here is what nobody tells you about that blue light. It is beautiful. In the photographs of detector tanks, You see those gorgeous rings of Cherenkov radiation, blue and precise, like a target painted by a master. And you realize that every single one of those rings is a ghost, caught, a particle that would have passed through your body without a trace, that spent its entire existence in darkness, revealed by one flash in a tank of pure water. That is the engineering. That is the build. That is the reward for 3 years of blasting, for thousands of tons of concrete, for the impossible logistics of building a cathedral underground. You thought the cavern was the hard part. You thought the water was the hard part. You thought the sensors were the hard part. They were all hard. They were all necessary. But the deepest truth of Hyper-Kamiokande is simpler and stranger than any of them. The deepest truth is that this detector is not being built to look outward. It is being built to look backward, to the very beginning of everything. The neutrinos it catches are not just ghost particles. They are fossils. They are the still visible afterglow of processes that shaped the universe, messages from a time when the universe was dense and hot and full of violence. When a supernova explodes, it releases more neutrinos than all the stars in the visible universe. Those neutrinos cross the cosmos, pass through planets, through the rock above your head, through your body, and a handful of them, a handful, interact with the water in this tank. That interaction produces a flash. That flash is detected. That detection tells physicists what happened inside a dying star millions of light years away. You are not looking at a construction project. You are looking at a time machine. And that is the uncomfortable conclusion. You, standing in the dark, surrounded by rock, looking at a tank of pure water. You are standing in the path of the universe's oldest messages. The rock doesn't block them. The darkness does not hide them. They do not care about the mountain. They only care about the water, and the water is ready. The implication for your worldview is this. You are constantly being passed through by information you cannot perceive. Every second, neutrinos stream through your body. Billions, trillions, numbers with no meaning to your senses. You cannot see them. You cannot feel them. You would never know they existed without machines like this one. And the fact that people built this machine, carved a mountain, purified an ocean, hung 20,000 eyes in the dark, says something about what human beings do when they decide to look. Every second you spent watching this, neutrinos passed through your eyes. You did not see them, but you know they were there. Subscribe, because the next project we unearth hides under different rock, and its message is older still. Comment the word that comes to you when you think of waiting in the dark. Patience, hope, nothing. I want to know what sits in your head now. By 95% of the way through, you have the answer to the original question. You know how you build a 260,000-ton detector 600 meters underground. You carve a cathedral out of a mountain. You line it with concrete. You seal it against the rock. You fill it with water so pure it is almost a vacuum. You hang 20,000 eyes in the darkness, and then you wait for the universe to flicker. You also know the thing that is never in the brochure. You know that the build is not a triumph. It is an act of defiance. The mountain does not want an empty space in its heart. The water does not want to stay pure. The sensors do not want to stay dark. Every single component of this detector is fighting against entropy, against the natural tendency of everything to decay, corrode, cloud, and fail. And the only thing holding it all together is human attention. Engineers monitoring the water purity, Technicians checking the sensors. Physicists reviewing the data. The detector is not a machine. It is a process, a continuous act of maintenance that will last as long as physicists believe it is worth the effort. You stand in the return chamber at the end of the tour, and you feel the silence. Not the expectant silence of a room waiting for a signal, the thick silence of a mountain that has been hollowed out and is still deciding whether it approves. The ventilation hums, the lights cast their industrial glow, and somewhere below you, hidden in the dark, 260,000 tons of water sit perfectly still, waiting. You think about the fact that you have been shouting your entire life into a universe that is largely silent to you. You think about the fact that the only way to hear the universe is to build a room so quiet, so pure, so dark, that a single photon is an event worth noticing. You think about the fact that this room exists because a group of physicists convinced a country to spend billions of dollars carving a hole in a mountain. And then you think about the fact that there are deeper holes, darker rooms, detectors being planned that will be even larger, even more sensitive, even more impossible. The mountain is not the limit. The mountain is just the beginning. The universe is full of ghosts, and the engineers are learning to catch them. The last image you take from the mine is not the tank, not the sensors, not the water. It is the access tunnel, the long sloping corridor that leads from the surface down to the detector's heart. You walk it once, at the end of your time underground, and you feel every one of the 600 meters as a weight on your shoulders. Not painful, just present, just constant, just there, always there, pressing down on the walls of the tunnel you are walking through. You think about the fact that the tunnel will be there for decades. The detector will run, and age, and eventually be decommissioned. And then what? The void will remain. The mountain will slowly reclaim it. The concrete will crack. The sensors will rust. The water will be pumped out, and the cathedral will become a cave again. Unless someone builds something else in its heart. That is the thread that stays open. The mountain has been hollowed. The corridor has been cut. The infrastructure exists. The next generation of physics, the next impossible experiment, will not need to carve a new mountain. It will need to climb into this one, look at the aging cavern, and ask, what do we build here next? You know the answer before you leave. You build deeper. You build darker. You build more sensitive. The ghost particles are still out there, streaming through everything, carrying messages from the edge of time. The engineers will keep chasing them. The rock will keep standing. The water will keep waiting. And you will never look at a glass of water the same way again, because you know what it could become. You know what human beings can build when they decide to look into the dark and find the light that was always there, waiting to be caught.